Hey guys, I'm going to be talking about solutions today and how water dissolves things and what does it mean to dissolve things and what's actually happening. The examples we'll talk about today are salt, and there's going to be a few things that we're going to learn, but the basic main point of today is what are solutions and how do things dissolve, okay? And why do some things not dissolve, right? So anyway, the first thing we're going to do, we're going to talk about some definitions. The first thing, if you look at these words, and hopefully they're right side up, or not backwards for you. It looks backwards on my screen, but that doesn't, I think when it records it doesn't. Alright, anyway, so the first one is solution, okay? We're going to talk about what a solution is. The next word is solvent. Actually, let me give you the definition. A solution is something that is, when you mix it together, it becomes one homogeneous thing, one solid thing. It's not little parts of things, it's one thing, okay? Take a second, and I want you to think, I'll explain these other words in just a minute, but let me finish explaining solution. Take a second and think of a slushy, okay? A slushy is little chunks of ice surrounded by water, and then there's another chunk of ice, another chunk of ice. It's like a whole pile of chunks of ice surrounded by liquid, right? Okay, that's a slushy. The same. So homogeneous means it's all mixed in throughout, okay? Then if you think about milk, let's talk about milk for just a second. Milk is not a homogeneous solution, even though it kind of in our cups to our brains to our eyes it looks homogeneous because it looks all the same. In reality, if you zoom in on a picture of milk, you can take a second, look it up in Google, do a quick close-up on milk. Milk, what it is, it's actually little tiny blobs of fat next to liquid. A little blob of fat mixed with the liquid, what they call, I think it's called the whey, I could be wrong. Anyway, but it's not a solid mixed-in thing. Have like water and salt. If I mix salt into water, water's the solvent because it's doing the dissolving. It's doing the work. It's dissolving the water, or the salt, sorry. Okay, solute is the item that's getting dissolved. So salt is a solute. Okay, sugar's a solute. It gets dissolved in water. This is the solvent is the one that does the job, does the dissolving, and solute is the one that gets dissolved. Okay, all right. The next one we're going to talk about is polarization. I'll explain that in a minute. We'll talk about ionic bonds as a review. We've already talked about this, and an ion, okay? And then we'll kind of just do a thing. Okay, all right. Turn my screen instead of on me. You get to see this. Let me turn it. I apologize that it's not the fancy way of seeing this, but you just get to deal with it. Okay, it's not even full screen, but that's okay. All right, so let me show you this. Okay, so this is basically going to explain to us how water dissolves salt. Okay, so that is a water molecule, and I'm going to be kind of explaining things as this video shows it, so I apologize for all the interruptions. But they tend to kind of stick to one side. Notice it doesn't have anything down here. They're not evenly spaced out. They're kind of stuck to one side. What that ends up doing is it ends up creating the electrons, remember, they're moving around the center, so they're kind of out here. They're moving around and around and around and around in their own little layers and stuff. And they kind of do patterns and so forth, but for the most part, they're moving around and around and around. Okay, the electrons are moving around and around and around and around and around. And what ends up happening is most of our electrons end up kind of over here because these ones are repelling it. So we end up with a lot of electrons here. And electrons, if you remember, are negatives. So I have a whole bunch of negatives kind of stick is positive and that side is negative, so we've got polars, the poles on either side, polarized. One of them is positive, one of them is negative. That's what that means. Okay, so what happens is because it is polarized, because one side of these water molecules is positive and one side of it is negative, and notice how they're kind of sticking together a little bit. Water tends to attract to itself because of that. So what happens is we've got this polarized polar charges, basically polarized. One side is positive, one side is negative. And if you look at salt, salt is made of, and I'm going to actually interrupt the video here. It's 9, and so it's missing. It's got a spot open. Okay, so what ends up happening is the sodium gives away its 11th electron to this guy, chlorine, I don't know, which takes that extra electron, and now it's got an extra electron. Okay, so this now has an extra one. It's no longer the same number of electrons. It's got an extra electron, which makes it an ion. An ion means it's got one too many or not enough electrons. Okay, this one has an extra electron. Remember, electrons are negatives, so this one has an extra negative stuck to it. If you want to read that, you can. I literally just explained that. But it says electron goes to the other one, leaving it with less negatives. So it's now a positive ion. The other one with an extra electron is now more negative, and that makes them attracted to each other. Okay? Alright, that's how salt is stuck together. It's basically a negative and a positive because they've given away their electrons and so forth, and now they're boom, stuck together. And like in this image, let me move it down again a little bit if I can. There we go. attracted, the positive side's attracted to the negative one, and the negative side's attracted to the positive one, and it just rips it apart. Piece by piece by piece. It just takes it apart, literally rips it apart. And the waters are attracted. Notice the positive sides are attracted to the negative one. The negative side is attracted to the positive ones. And that salt now is mixed up and all dissolved. So that's what's happening when you dissolve something. That's literally what's happening. The water's literally ripping it apart. And things other than water dissolve, like alcohol dissolves some things. Any kind of liquid dissolves things. Sometimes they don't dissolve certain things. They only dissolve certain things. Okay. All right. So if you've poured water inside oil, it just kind of blobs up. It doesn't, and it floats on top. Oil is lighter than water, so it floats, but it like blobs up. It doesn't, look at that, it doesn't mix in. So he's going to talk about why.
Refrigerator, but why don't oil and water normally mix? Water, H2O, is a stubby molecule with a slightly positive charge on the hydrogen, H end, and a slightly negative charge on the oxygen, O end. The oxygen atom actually steals electrons from the hydrogen atoms. Called a polar molecule, the negative poles on each water molecule are attracted to the positive poles on other water molecules, and as bonds. In fact, oil floats on water because it is less dense, with these super tight hydrogen bonds between water molecules holding them closer together than the bonds between the fatty acid molecules that primarily make up oil. As for oil, it's a non-polar chemical, since the atoms in the fatty acids in oil share their electrons nicely.
So all the atoms in oil, but this is the lines are just artistic. They're not actually there, but these just to show the attraction. They're not polar, so there's no positive or negative side. They just end up being kind of the same all over the place.
They usually have no charge, or at least not enough. Given that oil essentially repels the water, it is called hydrophobic or water-fearing, as opposed to hydrophilic or water-loving. As such, eventually all the lipophilic or fat-loving oil molecules will join together, floating on top of the water. However, although they seem determined to stay apart, it is possible to mix oil and water in a more or less stable solution, and there are several examples of this in your kitchen. One of the most common examples of where this occurs is in salad dressing. To get the two main ingredients, vinegar, essentially water with acetic acid, and oil to combine and stay that way for some amount of time, it involves two steps. Or emulsion.
Okay, so what ends up happening with things that if you want to mix oil and water, the only way to do it is just to put something in between. If you put something that's attracted to water and attracted to oil, like one side's attracted to water, the other side's attracted to oil, it will kind of bond the two together. Like it's the in-between one. So it's attracted to the water, but it's also attracted to the oil, and so it kind of bonds them together. It's like kind of like it's like hold hands of the other ones, keeps them together. So when you need something like that to make a solution work, they don't call it a solution anymore because it's not mixed in by itself. They call it an
dispersed, and since the emulsifier is there to either coat the oil or bind it to the vinegar, it will remain suspended in the mixture for a good deal of time. So I really hope you found that video interesting. If you did, please...
Okay. So hopefully that made sense, and if you have any questions, please talk to me. I am here to help. So if you're feeling confused, let me know. But just to quickly review, we talked about solutions, which are when something is mixed completely in. The solvent is the one that does the dissolving. The solute's the thing that gets dissolved. Polarization or polarized is when the molecule